am Revathi, Assistant Professor, Department of EEE, SNS College of Engineering. In this lecture series video of electron devices and circuits, today's topic is high frequency response of CE amplifier. So, CE amplifier in a sense, collector emitter amplifier at high frequencies, internal transistor junction capacitor do comes into play, reducing an amplifier's gain and introducing phase shift as the signal frequency increases. As the frequency goes up, the internal capacitive resistance goes down. At the same point, they begins to have a significant efforts on the transistor gain. At the lowest frequency, the internal capacitance have a very high reactance because of their low capacitance value. Usually, only a few power factor and the low frequency value. Therefore, they look like opens and have no effect on the transistor's performance. High frequency response of CE amplifiers, when the reactance of an CBC becomes a small enough, a significant amount of output signal voltage is fed back out of phase with the input negative feedback, thus effectively reducing the voltage gain. When the reactance of CBC becomes a small enough, a significant amount of signal voltage is lost due to a signal divider effect on the source resistance and the reactance of a CBE, where Miller's theorem states that inverting amplifier, it is the inverting gain that magnifies the feedback capacitance. Where in high frequency response of CE amplifier, Miller's theorem states that it simplifies the analysis of inverting amplifiers at a high frequency where the internal resistance capacitance are important. AV is the voltage gain of the amplifier at mid-range frequencies and C represents CBC. Miller's theorem states that C effectively appears as the capacitance form input to ground and can be expressed as follow. Miller's theorems also states that C effectively appears as a capacitance from output to ground and can be expressed. This indicates that the voltage gain is 10 or greater than C out. Miller is approximately equal to CBC because AV plus 1 divided by AV is equal to 1, wherein high frequency response of note common base and common collector amplifiers do not suffer from the Miller effect, since in these amplifiers one side of is connected directly to ground. As frequency increases, the capacitive reactance becomes smaller. This causes the signal voltage at the base to decrease, so the amplifier's voltage gain decreases. The reason for this is that the capacitance and react resistance act as the voltage divider, and as the frequency increases, more voltage is dropped across the resistance and less across the capacitance, where at the critical frequency the gain is 3 decibel less than its mid-range value, just as with the low frequency response. The critical high frequency FC is the frequency at which the capacitive reactance is equal to the total resistance. As the frequency goes above in the input RC, circuit causes the gain to roll off at the rate of minus 20 decibel per decades, just as with the low frequency response. Phase shift for input RC current at high frequency. Because the output voltage of a high frequency input RC circuit is across the capacitor, the output of circuit lags the input. As the frequency increases above FC, the phase angle increases above 45 degree and approaches 90 degree when the frequency is sufficiently high. At the critical frequency FC, the phase shift is 45 degree with the signal voltage at the base of the transistor lagging the input signal, where the two RC circuit created by the internal transistor capacitance influences high frequency response of BJT amplifier. As the frequency increases and reaches the high end of its mid-range values of one of the RC will causes the amplifier gain to begin dropping off. The frequency at which this occurs is the dominant critical frequency. It is the lower of the two critical high frequencies at the FC input, and the voltage gain begins to roll off at minus 20 decibel decade. So that the total frequency graph is plotted across the decibel and for hertz, whereas in the mid-range frequency is lower frequency is in the starting ranges and to dropping in the higher frequency ranges band. Thank you.